Our next speaker is a student in NCHU， 他是清华大学博士生，然后他现在在台湾，在清华大学做研究。那他今天要为我们讲一些NLP 的事情，他要比较 PyTorch and Tensorflow. He'll give us a talk about NLP on the comparison of PyTorch and Tensorflow. Please give an applause to welcome him.
Hello, everyone. Thanks for having me, and thanks for participating here. So my talk will be about deep learning for NLP, and I'm going to do a comparison between PyTorch and TensorFlow. I've been using TensorFlow from when it was initially released, and also PyTorch, but PyTorch was released like a year ago. So I will just show some of my experience in using these two tools for doing NLP and deep learning. So you can access the link here. I have some notes here, and I also have access to the slides if you wish. So about this talk, I will discuss how to collect a data set first, and then I will show you how to build emotion prediction models, and we're going to use some techniques that we may be familiar with, word-to-vec, LSTM, and CNN. And I will discuss the pros and cons of using TensorFlow and PyTorch. I will also evaluate some of the results I have with some of the data set and the experiments I did. And I will discuss opportunities and community. So I don't know how many of you guys have seen this wonderful movie about the emotions. Raise of hands, how much of you guys have seen it? Oh, wow, that's a lot. That's nice. It's a movie from Disney. I'm not sure when it was released, but it's basically about emotions and showing how emotions work as you get older, how they evolve, how they behave, right? And so my question was, when I saw this movie the first time, why are there only 5 emotions here, right? That's a question that really bothered me because I actually do emotion analysis as a researcher. So I kept asking this question a lot. And who is missing? So the general idea of this movie is that there are 5 key emotions, and they are supposed to be the universal emotions. So how we communicate today, maybe there are more. And that's kind of the question I aim to answer with my research and some of the things I will discuss today. So about me, I'm a PhD student at NTHU. I'm on my 3rd year. I'm from Belize. I don't know if you can see this emoji here, or if you are familiar with this emoji here. So that's a Belizean flag. And you can find me on Twitter here. So my field is machine learning and natural language processing, with a main focus on computational health and emotion analysis. And some of my hobbies are online teaching. I do teach a lot using YouTube and other tools. I do a lot of sketching in my free time, and I also do a lot of writing. So about emotions, I discussed a little bit about them, but not too much details. So main challenge with emotions and studying it is that there's no universal definition for emotions, right? And some may argue that there are, and some psychologists may argue this, but there is no universal definition. Everyone has their own. And even if you go to the Wikipedia page and you search for emotion and you look at the definition, you won't really find one universal definition, which is strange because we use emotions to express and communicate a lot. So you can see here many different examples, right? You can see those emoticons here. You can see the line stickers, what we use in Facebook now, very popular. And Twitter also, we have those hashtags that we use to express some sarcasm. So many different ways to express emotions. There's a field called Affective Computing, and this is what the field of studying emotion is called. It's basically to teach machines how to recognize and express emotions. Now, we deal mostly with the recognize part, but other researchers also deal with express, where they build dialogue systems. And you have 2 machines interacting with each other, or you have someone, a person, a human being, and a machine interacting with each other. So many cases how this can work. So we have 3 forms, or what we call modes, of communicating emotions. We have voice intonation, facial expression, and linguistic cues. Voice intonation is much speech. If you're interested in speech research, you might have done this part. Facial expression, people doing computer vision also are doing a lot of emotion recognition studies, like detecting emotion on videos and stuff like that. And my part here is the linguistic cues. Now, as simple as that may seem, those texts here, it's very hard to extract valuable information here that represents something as expressing emotion. So it's very challenging, even though it looks as simple as this. So my motivation for working with emotion artificial intelligence is it could be useful for building chatbots, which are very popular today. It's also useful for stock market prediction. And it was famously used like 3 years ago for predicting elections. It's very, very useful for that. And also, emotions can be used to understand other emotion-induced behaviors. So, like sarcasm I mentioned, hate speech, and mental health. And I'm very, very interested in this one because of many of the issues that are happening online and the usage of online tools like social media. There's a very nice website here also. They use a conversational bot to keep track of your mood. And so you can communicate with these chatbot, and you can, they give you suggestions to what activities to do based on how you feel. So we are a long way already in what we can do with emotion intelligence. And there's a lot more to come. So I'm very excited to be in this field. The problem here that we want to address is to build a text-based emotion detection system using NLP and deep learning. So we used machine learning before. We use a very simple techniques to do emotion recognition. And we use various different modes like videos and images. But how do we use NLP and deep learning? That's the question I am to address here. This is kind of a rough overview of the system. So we have our messages over there. We have some system that we want to build, and I will show you how to do that with using those two tools. And we have here what will be the prediction, right? Whether it will be happy, whatever, one of those emotions, right? And that prediction may come in different forms. Prediction can be an emoji prediction, or it can also be a hashtag, or it could be a label, right? It could be different predictions depending on what your data set looks like. And why I use these two tools, of course, there are other tools like Keras, Caffe, and other tools. But why I choose this one is because this one is very recent, and it has a lot of useful techniques that we can use, especially researchers and developers. So the tools. First, we collect a data set, we transform it, we build a classifier, where we're going to use CPU or GPU, that's the question too, and then we evaluate using scikit-learn, right? That's kind of a basic step for machine learning. So these are just commands, useful commands to get those installed. If you don't have, you can get those in the slides. So the key thing here about these two tools is that they're very recent tools, and they are very good at deploying machine learning and deep learning algorithms. So TensorFlow was developed by Google Brain in 2015, and PyTorch was built on top of Lua Torch in 2016. So they're very recent, right? They're very recent tools. And why am I saying comparing giants? Because from the community, what I've seen is that these are kind of two of the more popular tools being used. So I kind of just did my research and wanted to know, why would you use this one as compared to the other one? So here are some comparisons. So with PyTorch, models are built as a directed acyclic graph. Also, TensorFlow, also same concept, right? But what's the difference is that TensorFlow is built on something called a static graph. So you build your architecture, then you train a model. And with PyTorch, the beautiful thing is that you create a dynamic graph, which feels more native if you are a Python user, right? They're both built on Python. So it's more native. And that's kind of one of the advantages. And in terms of debugging, if you're familiar with TensorFlow, you will notice that It's very good at debugging. PyTorch, not so much, but still useful. Visualizations, there's this famous tool here, TensorBoard, very, very useful. I use it a lot in my research, but there's no equivalent for PyTorch. As I said, it's a very recent tool, library, so there are no like visualization integration. If you want to do visualizations, you have to use the matplotlib, right? So there's no equivalent for PyTorch. PyTorch requires a lot of manual work, right? While TensorFlow, you can deploy models even on mobile. So let's say you want to do deep learning and you want to deploy it on mobile. It will require a lot of work. You build your APIs from scratch. It takes a lot of work, but there are more tools here for TensorFlow, more support for that. So no support, and has distributed training, right? Where you can distribute your task to multiple GPUs if you have multiple servers, but PyTorch doesn't have support for that. So that kind of support is coming soon, because they're going to release their production mode in a couple, maybe a year or so, before a year. So also data parallelism, which is very useful also. If you don't have resources locally, you can use it remotely. It's very useful. And actually, PyTorch has a focus on data parallelism, so it's much easier to do. While TensorFlow, it does give you the tools, but you have to do it manually. You have to do a lot more work as compared to PyTorch. So in general, PyTorch feels more like a framework, and TensorFlow gives you a lot of control. So you're building things from scratch, and if you are that kind of developer that wants to know everything that's going on, then that's you here. But it requires a lot more work. So for me, that I'm a researcher and I need to build quick tools, do quick experiments, this is the tool I favor because it feels more like building blocks, so it's very nice. So PyTorch, you can get started very fast. And TensorFlow is excellent for production. And if you use this a lot, you will know that. That's the main difference. And you can find more information about here. It's a nice little article that you can look at. So that's how I see these two tools. They're both very useful tools. And I hate comparing both of them. But I need to compare both of them because I use them a lot. And sometimes I would favor, in some cases, I would favor PyTorch, and sometimes I would favor TensorFlow. So it's good to know both of them. That's what I'm trying to say. So this one is more like, okay, you have some building blocks that you build very easily. You don't have any kind of prototype you're following. You just have flexibility. And TensorFlow, the same. But the difference is that it's kind of like, okay, you're more involved in the work, right? So you can see the child here is very happy. So you feel more involved. So the data set. We need large-scale annotated data sets, right? When we're dealing with deep learning and machine learning, we need a lot of data. And I actually have a lot of techniques. I've written a lot of papers in emotion recognition for text-based medium. And there are many ways you can collect data. It's very smart ways to collect them. For example, we have on Twitter, we can collect using the hashtag, right? And it's a technique, well-known technique called distance supervision, right? So these are very weak labels that can represent the meaning being conveyed here in the text. So those will be your labels. And you can further categorize these into more finer grain emotions. So for example, this one will fall under joy. So whoever you wanted, you can categorize them. Right? So a first look at the data. Actually, I got this data from this repository here. A very, very active developer, and he has a lot of NLP resources. So I kind of share that resource here for you guys if you're interested in that. And he has a lot more NLP data sets that are very useful for doing deep learning. So the data was collected using power of speech, some synonyms, and other data augmentation technique. You can read more about it, how it was collected right here. And that's how it would look. It's just a little preview of what it looks like, right? So we have a text, and we have some label here. I read a label for you, so you don't have to do labeling. So that's the distribution. And why I wanted to point out the distribution is because with most emotion recognition studies and sentiments analysis, you'll find that the data is usually very imbalanced like this. So you have sadness and joy. Again, you can see some kind of universality here. Okay, you see joy and sadness, which are the more universal emotions, and you kind of go more here. Okay, so that's kind of one thing you have to deal with when you're dealing with emotion studies. So think of that in the imbalance problem. And there are other cases where this is also a problem. And the number of words in this data set here is roughly 70,000. I just showed a little snapshot here of my Python notebook. You can see the words, right, kind of portray some emotion here. So the next step after we have collected our data, we have our large-scale data, which is useful for deep learning, right? If you're doing deep learning, the thing is you need a large-scale data set, right? So now we're going to transform this data. So we have bag of words, which I think people that are doing machine learning might already be familiar with this one. And we have something called the n-grams, which is just sequences of words, and character embeddings, and word embeddings. And there are many other different types of transformations that we can do with our data set so that we can feed into the algorithm, right? So what does that look like? OK, let's review what bag of words are. Just a quick overview of it. So how do we represent the sequence, the sentences that we have? So usually it would be something like this. We have the word, I love the coldness. And wherever the word appears, for example, love would be represented by a 1. And these ones are just missing values. It depends on the size of the vector. So you can see here the 1 represents the word. And that's kind of a bag of word approach. And you will feed that into a neural network. And that's basically how you use bag of words. But the question is, and the problem is actually, bag of words cannot really preserve order, right? So, and it cannot capture any semantics. Why? Let's see. Let's look deeper at the example. So let's say we have these two examples here. The food was good, not bad at all. The food was bad, not good at all, right? But don't be confused. The difference here is that good and bad, right? They're not in the same place. And because of this shift, the question, the sentence, the meaning changes totally, completely. But how to represent this into a machine? How does a machine understand what's the difference between the two? And why is this important, by the way? Well, because they both convey very different emotion meaning, right? So that's kind of a problem I had to address initially when I was working with this. So they would represent, with a bag of word method, they represent the same thing. So the same vector for both of them. And that's already a big problem for your models. So both representations are the same, even though they mean different things. So one-hot encoding, another very popular technique. On Monday, it was raining, and you would have some representation like this in one-hot encoding. And you can see the position is different for each word, right? That's kind of the difference. Does it work? What's the problem here? Let's see what the problem is. So we have two different examples here. On Monday, it was raining, and it was raining on Monday. Do they mean the same thing? That's the first question. Do these two statements mean the same thing? They probably do. Probably do, right? It depends on it's very subjective, actually. But you can see here that they are not the same representation, right? So that's an issue here. Even though those traditional techniques are good, for some cases like this, very special cases, not very good. So I cannot deal with variations of the sequences here in the word. So what's next? We definitely need more robust and natural structures to model the language, right? And we have seen a lot of the rise of deep learning techniques used for doing exactly this problem, dealing with this problem here. And that's what I'm going to discuss next. The first technique is word embeddings. As I said before, semantics weren't really captured very well with the bag of words method. And there's a new technique called word embeddings, very popular, used in many different problems. And sorry, see. So the basic idea is that you can represent words using some vector representation. And this vector representation contains what we call latent features. So some feature learn about the data. Maybe this word is a person. Yes, it's a person, but it's also something related to royalty. Right? It has some status, and many different things can represent this word. And the same thing with man, woman, and queen. So there's some relationship with man and woman and king and queen in this case, right? Because of those latent features. And so even though this is a very useful technique, one of the issues with this technique is also because of these latent features, right? You don't really know what's going on. And recent work have done investigation in what kind of features are being learned here, right? So, but in general, it's a very useful tool, a very useful technique. And you can read more about it in the paper here, very famous paper. Pre-trained word embeddings. So there are two ways you can use word embeddings. You can use the pre-trained models, right? You can use these ones that we might be familiar with, Google Word2Vec, Glove, and recently there is Twitter-based Word2Vec, which I use a lot because I use Twitter data, so it's kind of more relevant to my stuff. These ones I think are trained on Wikipedia data. So this one is very useful also for dealing with Twitter data. Or you can train your own models. So let me just get like a raise of hands. How much of you guys have done Word2Vec, used pre-trained models? Just the pre-trained models. Okay, not a lot. How much of you guys have trained it from scratch? Okay, a few. Okay, excellent. So there's a reason why you would want to train your models from scratch. First of all, let's say you're dealing with Reddit data and you're using a Twitter Word2Vec. You can see a problem there because it was trained on different data sets. So if you're dealing with Reddit data, you would want to train your model, your Word2Vec from scratch. So I would just show you some screenshots on how I did this. And later on, I will also share the code. I don't have the code online because it still has some little things that I need to change, but I will share that. So the first step is, assuming you know what the data set looked like, I showed you before, and the first thing is convert words into indices, right? So you can see that each word, I show you the vocabulary here, has a corresponding index, right, on the right. That's the first step. It's a very easy way very easy to train these models, by the way. It shouldn't really stop you from training your own, Word2Vec or converting your own models or Word2Vec. So right here, you can see the context words. So for example, here we have 1, 8. So those are indices of words. So you can see 8, 1, right? 1, 8. So the value here represents the target, right? So it's like training a completely different, like a deep learning structure, right? Using some data set, and this is your data set, basically. The words are your data set, the words in the corpus. Right? So it's very similar to when you have your words, and your target, and your text. So these are the target words. So for example, here the 370, you can see here, awful, that would go here. So that would be the label, right? And just as an example, let's say we create a batch, right? So now we have the 1.8, feel, about, and we have the 370 here, which will be the. So these ones will represent records, right? And that's a batch. So the next step is we have our input. It looks like that, right? We create like a little structure. What are we going to use to create this structure? This very simple neural network. And we have a hidden layer, we have an input, and we have an output layer here. And those are our Ys, right? Our targets. That's basically the idea of the CBOW. This is just like training a neural network, very simple. So I did the training for using both tools, and I wanted to know what the difference was. What's the advantage of one of the tools compared to the other one, right? So if you're familiar with TensorFlow, this is basically what the code looks like, right? So create a graph, and we create some placeholders where our data will be transferred into the model, and then you can see here. So that's how you handle their data. Create embeddings. This takes care of everything for creating the embeddings. And that's how you compute a loss. Then you do some backpropagation, and you're basically almost done. So that's TensorFlow. PyTorch, now, I wanted to show a difference. Like I didn't say here, but you notice here how we compute loss using this very nice little function here, right? NC loss. So I will discuss more about this function later and why it's so useful. But you notice here, I don't have anything about NC loss. If you take a quick look at the data, at our code here, you will see that even the way I construct the structure of the neural network is kind of different. Right? I don't have a side-by-side, but if you have the slides, you can notice that. It's kind of different. You can see here, we have our important variables. No such concept as placeholder here. Everything is just what we know as functions and parameters, and that's it. We don't have any special placeholder. All right, and we compute our probabilities, and we're almost done with the training, building our architecture. So you can see there's kind of some advantage using this model because it's less code and it looks more cleaner. But is it always the case for every model you build in deep learning? No, not really. I will show you that in the next. So one thing to pay attention to is how implicit everything is when you're building something with PyTorch. How much of you guys use PyTorch, by the way? Or have used PyTorch? Okay, one person, okay. So you can see here, it's not so, right? Everything is just very implicit. We created right here, a hidden layer, this way, and with this line of code, but there's nothing, where are the weights? Where are our, those parameters, right? Or bias, where is it? There's not to be found here. Everything is contained in this line of code. And that's the beauty about PyTorch, right? That's one of the advantages is that you can just quickly train models, quickly build models and train them very, very fast, right? With very little knowledge, by the way, because you don't need to know what's going on here. And actually, they tell you that you don't need to know. As long as you know what your input looks like and what your output looks like, that's basically what you need to work on PyTorch. So I put right here side by side how to do the training. You can see here that there's a special command here called, and I'm quickly going over this. You have the slide so you can take your time and look at it. But I just wanted to highlight the most important parts. So here's how to use GPU. All right, you can use your CUDA here, right? And you have what's called of course, if you're going to use Atom or going to use SGD, what's going to be your, technique to do the backpropagation here, and very basic steps to do training. Right, and doing a batching here. It almost looks the same, but the difference is this block of code here, right? So where you do your backpropagation, and do an optimization is done in the batches themselves. So you see nothing like that here, right? So everything is kind of concealed for you. So you can see the difference. There are two different approaches to building, but achieving the same, the same goal at the same time. So it's very good, for me, for my experience, it's very good to know exactly what's the next step by step by step. But in some cases, you don't really need to know what's going on, and so everything is just hidden. You can access everything through this session. So that's kind of useful. So you can see the pros and cons here. It all depends on what you need. So it feels more native. It's a step-by-step approach. And notice that the loss and backpropagation are computed right in here where you do the training. And TensorFlow focuses more on building architecture than train. Right? You will build the architecture before, and then we train in this step. So two different parts are just separated from each other. Right? You may prefer that case. So it trains much faster because of the NC. I showed you the little function, right? So the thing is, when you're building CBOW, you have a lot, so your vocabulary is, let's say, 70,000. That's a very small case. Sometimes you'll have like 3 million words in a data set. So what that means is that the output layer will have almost the same size as your vocabulary. So you can imagine how much comparisons are being made. So a very nice little function here to deal with that problem. And I won't get into the specifics about that. You can read more about that if you're interested in building your own word embeddings, own word vectors. Okay, so the next step is to, okay, we train the CBOW, right? What do we do next is we want to store those parameters, right? We want to store those vectors, those word vectors, right? So instead of using the pre-trained, now we use our own word vectors. And we can just store them using Pickle. Very simple, using Pickle. For both cases, it's the same. So there's no like bad thing I can say about the two models. You can do that very simply, but it's just a different command. Eval, and this is a different command. But it's basically the same step. And you can load them. Once you have saved them, you load them, and it looks like this. So for example, the word field has this vector representation here, right? With all those numbers here that represent latent features. Right, so this one, I think, is 128 size. So you can see that right there is what it looks like. So in general, the TensorFlow gives more flexibility on how to save the model. But however, it takes more time. You will find that this is all you need here. This step is all you need. But you notice here, I'm doing kind of a lot of transformations. I'm doing that data, that CPU, that NumPy. So it's a lot of tiny little transformations that I'm doing, and those tiny operations actually take a lot of memory. So that's kind of one of the disadvantages here with using PyTorch. But in TensorFlow, everything is much quicker. So time to train the model. We have our word vectors. We have our data set. It's now time to train the model. And we're going to use, as we said before, we don't want to use a bag-of-word approach. We don't want to use those traditional techniques. We want to use something that's more robust. So we rely on the LSTM, right? This is a family of neural networks related to recurrent neural networks. And these are our hyperparameters, right? And this is what our architecture looks like. Very simple architectures. Our word embeddings are fed here. And we have some fully connected layer. And then we have a softmax. So if you're familiar with deep learning, this is very simple model. But why do we want to use LSTM, as I said? Why do we want to use something so complex to solve not a very difficult problem, because our data set looks like a very simple data set, right? Because the first thing was that we wanted to represent the language model, right? We wanted to use something that's more native or more natural to represent sequences. So using the bag-of-word, we saw many of the problems, right, with why LSTM. So we want to, right, we know that the current values depend on the previous ones. So I took the bus. We know that something has to go before that in order for bus to make any sense, the word bus. Right? That's kind of one example. And order needs to be maintained to preserve meaning. Now I'm talking about structure here still. Right? So you can see the order matters. If we put bus here instead of the word took, everything just changes, and we don't know what we're talking about here. And sequences usually vary in length. So the other problem was that with the traditional models, everything has to be fixed. The input has to be fixed. Everything has to be of the same size. So for example, if you only have 4 words in a sentence and then you have 10 words in a sentence, you have to do some special, like padding or something. So with RNN or LSTM models, we don't need to do all of that. Everything is taken care of, and you just need to do the representation with the word vectors. That's all. So it's time to train the models. Now, there are very important steps that we need to take. We want to split the data into training, validation, and testing. And then we tokenize the text into words. And then we convert words to vector representations. Again, we have that already, right? We store those, and we have those. So we have everything we need already. And the last step is just doing batching. And then we train. So how to prepare the input, right? How to prepare, we have our data set here, and I showed you the steps. So the first 2 steps is, okay, we're going to split our data into training, validation, and testing. We have 3 separate data sets because we want to test how general the model is and how well it's learning, right? So these are useful for that, and this one is useful for evaluating how generalizable your model is here. So we're going to tokenize text into words, and I use pandas here, very useful. And we have our text, and we convert them into tokens, right? So we have tokens here, and I have a little transformation here also that represent what the emotion is. So it's just using one-hot encoding. So this is all useful for the algorithm to have it in that format. So we have our input, right? We have our tokens, right? I show you the tokens. Sorry. We have our tokens here. All we do now is, okay, we want to represent this text here into something that we can feed into the model. And we say we're going to use embedding. So we're going to convert each token into its word vector. So for a sentence, let's say this is the example here, this feels fantastic. We have some transformation, and we have these vectors, right, concatenated. So it's like a long list of arrays, right? And that's going to be our input, basically. That's what it looks like. And now that we have done that, now we do batches before we train. So one of the things I learned this year, like when I really started to get into deep learning and NLP, is that this is one of the most important steps in your whole training. And sometimes we rely on something called the padding, right? So we have, let's say this is one of our batches, and we have sentences of this length. So token size, I have that here. So let's say that's like kind of the size of the sentence. You can see here different batches have different sizes. And you just pad it, right? You just add those zeros or whatever you use for padding, and that's how you will do the padding. But then there's a very useful and very efficient technique of doing padding by bucketing. Right? You can find more about it here in this link. And why it's useful is because now instead of doing this, which may not be too efficient for the model, because again, we're using a lot of padding. So in this case, we're using a lot of padding, and this one will not really work well for the model. So we need less padding. That's basically what I'm saying. And with this bucketing approach, you kind of select sentences from your data set that are of the same size, and then you do the padding. So now you minimize the padding, right? So you see the padding there. It's very small. So it's a very neat little trick to do more efficient batching, which in the end favors the model when you're training. So token size. So we have our LSTM. This is how I will build the models. Maybe you have a different way of building them. But you can see here how it changes. Before, we saw a lot of code when we were doing the word2vec. We saw a lot of code for TensorFlow, and while we use a very, very, very small snippet of code for PyTorch. But now you can see how PyTorch changes, and I'm trying to do it as efficient as possible. You can see what's the length. You can see a lot more things being done to build this LSTM layer, this architecture. And for TensorFlow, you see everything. It's just like a line by line. Everything looks very neat and organized. So again, you can see that the pros and cons change for a different scenario, for building a different architecture. Right? That's kind of one of the things I learned when I was building these models. So again, like I say, TensorFlow aims for flexibility, and PyTorch aims for quick building. Even though it's a lot more lines of code, I don't really need all of this code here. I could just remove this code and just quickly build my model. But with TensorFlow, it's more flexible, and you know what's going on. Every step of the way, you know what's going on. So that's kind of the benefit. And after training the model, I did it in maybe like a day. So I have my models, I trained my models, I got my word2vec very easily. I did this whole thing in one day. It was very quick. Because I have a data set, by the way, which is very, very good. I showed you the link before. This is the accuracy of the model. We have very high precision recall and F1 score, and the accuracy of the model is 89. That's very good. And you can see here a confusion matrix. And I did all of this using the scikit-learn. So while doing the models, I also found out that there's not really a good tool for doing evaluation of your models. So I had to rely on something like scikit-learn, right? And even though this one is not really used more for machine learning, it's still used for machine learning, but now a lot of people favor TensorFlow, Keras, and those models, right? And those tools. So, but it's very useful for doing evaluation. So you can see here what the confusion matrix is saying, that okay, most of the times, right, the true label was predicted right. So both models perform similarly well from my conclusion, and they take almost the same amount of time to train. And that's something that was kind of surprising to me. Even though these things were built very different for very different philosophies, they both perform well and they both train with the same time. So then we have the same output. It's just what you prefer to use as the algorithm and for building your architectures. And there's something interesting about the results. If you notice here, as I mentioned before, so the category love was predicted a lot of joy, because these two emotions are actually kind of related. So you can see here that the model, even though the model does very well for both categories, there's some kind of confusion going on here in the model, right? That's something that I can improve. So many things you can try. You can try to collect more data and retrain CBOW. You can store new embeddings. You can visualize embeddings. You can tune hyperparameters to increase the performance of the models. And you can try deeper LSTM, or you can try newer ones like ByLSTM, right? Which capture context much better than our previous model. So I actually put a little plug here for one of the papers I recently published. So you can find that here. I actually do a lot of research related to emotion analysis and sentiment analysis, and actually computational health as well. So you'll find those material if you're interested in reading. I also tried CNN models. I'm not a big fan of CNN models. I think it's mostly used for computer vision, but they work very well for language as well, which is something very interesting, because they're not built for that. So this is how I built my architecture. Again, there's not much difference, again, you see here. But one of the cool things I found is that, because there's something in CNN model called the filter sizes. And the way I created my filter sizes, when you have time, you can look at the code, it's very, very different. I feel completely different when I'm kind of creating that important part of the CNN structure, right? I felt like the coding was different, and the whole experience was different. And I felt like it was much easier for doing with PyTorch. Even though I'm using this for more time, I felt like it was much easier here. So it's kind of like, for me, it's so interesting that two tools basically building the same thing, but slightly different, you know, in some cases. And other things you can try with the CNN, I will have code for that for you guys if you're interested in it, at the link I provided. You can do power speech, languages, you can try with many different languages also. And you can use many different types of information. You can combine video, images, and text into one, which is kind of the trend right now with sentiment analysis and emotion recognition, so it's combining different modes. And also emoji prediction. You can check this very nice trending topic here. You can do some error analysis, and you can actually discover hidden emotions. That's the whole point of doing this deep learning thing, right? It's not just for getting performance, but actually understanding the problem that you're addressing. So, going back to the movie, I would like something like this. More emotions. We have more emotions. I do think we can discover more emotions. So, lessons learned overall. PyTorch is faster for building deep learning models, from my experience. But TensorFlow ensures that you learn and have more control. So if you're just starting, I would suggest you start here, then you move on to this. But overall, data is the bottleneck here, right? I showed you many ways how we can collect data sets, and you can get very creative. I saw a nice presentation before my one that showed very nice ways to build ontologies and things. That's kind of a very creative way to collect a data set. So again, data is the bottleneck. From my experience. The future is emotion recognition in general is a very young field. So if you're interested in that, come and talk to me. If you're really interested in it, you can look at those papers as well. And it's very useful for building dialogue systems and empathy-aware chatbots. So in the future, when we're building these kind of machines and artificial intelligence, even though they know a lot about our world, it's important that they also know how we feel about different things and how we communicate, right? And there are some announcements here. PyTorch is going into production just like TensorFlow. And TensorFlow just recently announced TensorFlow.js, deep learning for the web. So many different trends that are happening with these tools, and it's very nice to follow that. Just some community stuff that I started here. You can look at that also. So in conclusion, PyTorch is made for developers and researchers. PyTorch is built for quickness. TensorFlow is great for production and great for learning. And TensorFlow is more flexible and gives more control. That's it. Thank you very much for your attention.
All right. Okay, thanks for the talk. I think we have time for a few questions. So if there are any, yep, 1 second.
I'd like to ask, you said that you use you put on the tokens for your data.
Sorry, I didn't.
You put on the tokens for your data so that you can use that for the training your models, right?
Yes.
Is that you have to manually doing that, or you have some automatic way to put on these tokens?
Right. That's a very nice question. So it's very flexible, right? You can use there are things called like ontologies. Actually, you can use ontologies to create those categories. And what I usually did in the past was I follow some very simple method. Like I would, let's say if you know thesaurus.com, for example, you search for the word joy, and it gives you some synonyms, right? So already the word joy has some relationship with those words like synonyms, and you can use that as to represent the emotion of joy. So in that case, we only have 6, right? But we know in our data set we have a lot more labels, but we just categorize them into one. But many different strategies you can use. And if you're really interested in that, you can look at the paper. I have all that information there if you're really into it.
Thank you.
Okay, and I have a question about the web embedding part.
Yeah.
It's about how do you deal with text encoding in Unicode, like Chinese words? Yeah, because when I trained myself, my work vector from scratch, and I found that different ways to do segmentation on Chinese words influence a lot on the final work vector I got.
Right. So yeah, another good question. So working with different languages, right? So one of the things right now I'm actually working on Japanese data, and one of the things I found out is that you really need a good segmentation tool, right? You really need a good way to tokenize those information in a way that it really benefits the way how to create the vocabularies first, and then you can train the word embeddings. But I don't really have experience with the Chinese data set, so I won't be able to give you like suggestions on what you can use. But there's a lot of literature that you can look at, and it shows you how to tokenize your text. But I know for Japanese, for example, they're very scarce. The tools are very scarce. So even though it's a really nice technique, there's some limitation, right? Especially with the segmentation part. Yeah.
All right. Yep, good one.
My question is, I have much experience with TensorFlow already, but what I know, as far as what I know, you can serve TensorFlow's model in a protobuf file. Like you can freeze it and it's like Pickle. You can reopen it, load it, and run it in a new program. But I have limited experience with PyTorch for now, so I want to ask: is there any concise or maybe proper way to serve or to save a PyTorch model like TensorFlow?
Yeah, a very excellent question, because actually the community is right now working on some way. Actually, the next version is going to be, they already announced it, they're going to have new functionalities. And one of those functionalities would be to better store models, because you saw in the example I showed, there's a lot of little quick things, a lot of little steps that you need to take to store the model properly and be able to restore it. But if you go into those forums, you will see like it's very inconsistent, right? People use different strategies to, you know, some people convert it to NumPy, some people just do it with the actual PyTorch libraries. So it's not so consistent. But it's a good question. But I think right now it's not really supported by PyTorch. But in the future, they're looking into that problem because it's kind of a very important point. Yeah.
Thanks for your talk. And as I know, there's another database called SentiWorldNet. It's another really nice database for sentiment analysis. And I'm wondering that what's the difference between the SentiWorldNet and the neural network? Can you give me a really short example to talk about the advantage of two? Thanks.
Yeah, so SentiWorldNet, there is like WordNet Effect, there is emotion lexicon, there are many different word banks that you can use, right? So the disadvantage is that you're actually relying on a manual resource. And that's kind of one of the main disadvantages, is because those like WordNet Effect and the SentiWorldNet, they're built by experts. So when you go and use those models, they're very reliable, high quality. But the difference is that they won't have content that we use today. For example, in the emotion analysis, we saw that you can use different ways to express different emotions. We have a lot of slang. We have many different ways to say different things. So those slangs and those examples that we use now, like emojis and this kind of way to communicate, you won't be able to find them in those word banks. And that's kind of the disadvantage here, one of the main advantages. Yeah.
Okay, so due to the time restriction, so we don't want to delay your lunch, so let's give another round of applause to the speaker.